Okay, folks, today we're going to talk about the two concepts in the third section of your chapter on evolution. These are two concepts that are related to how organisms become new species, okay, how new species are formed. The first concept is what is required for a new species to form, how do new species form, and the second concept is the concept around what is the rate of change? What is the type of change? Is it gradual or is it stepwise? So, first concept, how do new species form? As your book says, new species form when a group of organisms of one species have been isolated from another group for long enough that they develop enough different traits that now that group, if it mated with the first group, now that isolated group, if it mated with the first group, the group from which it broke off, either it wouldn't be able to have children or the children, the offspring wouldn't be able to have children. So that's, of course, when you have a new species, because a species is a group of individuals who can mate and have offspring that can have offspring. Okay, so we talked in that definition of how species form. We came up with two requirements. One is isolation. Okay, so a group of individuals has to be isolated, kept apart from the rest of the individuals. And very often there's a geographic feature that isolates the individuals, like water, a river, a sea, or a mountain range. Those are the kinds of things that can isolate species from each other. Of course, if the environments are different, like the dark lava and the tan sand that we saw with the rock pocket mice, that may help sort of speed the change along, because there may be some obvious environmental differences that strongly favor particular new traits. So, two things you need are isolation, and you need a huge amount of time. You need a lot of time. Of course, you need a little less time, typically, if there are huge environmental differences in the two areas or the multiple areas among which your group of organisms who are all of one species are now isolated from each other. So this is how it works. One group is one species all together. Somehow various groups get isolated from each other. 2 or 3 groups now are isolated and are separated from each other. Those separate groups mate with each other, right? And when they mate with each other, different mutations come up in the different groups. And those mutations, if they are adaptations and if they're heritable, they will become more and more predominant in the population. So now you have a population over here and a population over here, and they have different mutations that are now becoming more and more common in the different groups. You get enough different mutations that become the standard in different groups, and now the individuals in the group on this side of the river are very different from the individuals on this side of the river, and eventually they can be so different from each other that if somehow individuals from the two groups meet and are able to mate, either they can't have children or their children can't have children. Now you have 2 different species. Voila. Okay. Now, the other concept in this section of the chapter is rate of change. Okay, so how long does this take? And the answer is very, very long time. But what we are really concerned about is what's happening over this time. And there are 2 theories about what's happening over this time. One is gradualism, And that is the theory that our friend Charles Darwin had. And it made sense given his life experience. He understood, he came from a society, from an agrarian society, a farm society, in which people had been intentionally breeding certain traits into plants and animals for thousands and tens of thousands of years. And what happens if you do that intentional breeding is you see small changes, single changes from generation to generation to generation. But over time, over a large number of generations, those small changes add up to big differences. So thinking about our shape species, so Charles Darwin, given the world he grew up in, the agrarian world that he grew up in, he leapt immediately to the thought that evolution, when it's not managed by humans, may work the same as when it is managed by humans. And that's this gradualism idea. And using our little shape species example, I'm gonna show you in sort of picture form what the two ideas look like. So this is gradualism, and so what you see is over a long period of time, you see small, individual, discrete changes. Okay, but if you look from where the organism started out to where it ended up, those changes have added up so that this organism now is very, very different from what this organism might have looked like several million years ago, let's say. So now let's put some time on that. So let's say our more complex one down here at the bottom is today, and we're going to say the one change back is 1 million years ago, and 2 million years ago, and 3 million years ago, and 4 million years ago, and 5 million years ago. Okay? Now, let's draw a picture that illustrates what punctuated equilibrium might look like. So in punctuated equilibrium, you're going to start out, the theory is that in our picture, we're going to start out with the same thing we started out with, and we're going to end up with the same organism that we started out with, right? So this is the theory that says to get from this organism, this simple organism, whoops, I didn't mean to close the legs. We'll just have that be open, pretend that's open. In fact, I'll just redraw it. It says, yeah, over 5 million years. Note the same period of time. We start out with this organism and we end up with the same organism. And that period may take the same amount of time. Overall, but here's the difference. In punctuated equilibrium, our simple organism looks the same for a long time. And then all of a sudden, we have an organism that has a lot of changes. So, my goodness, for 5 million years ago, it looked like this. According to punctuated equilibrium, we'd say, no, this is really the pattern that happened over the time. The organism remained unchanged for 2 million, somewhere between 2 and 3 million years. And then the next time we see it at 2 million years, my goodness, there have been a number of changes to it. And then it remains unchanged. And then the next time we see it today, there have been another big group of changes to it. So So this is sort of a schematic of how gradualism and punctuated equilibrium are different. It's not that the whole host of changes from start to finish takes a shorter period of time in punctuated equilibrium. It can take just as long to get from the first one to the last one in punctuated equilibrium as it did in gradualism. The difference is that according to gradualism, you got from the first organism to the last organism via a series of discrete, simple, small changes. Whereas in punctuated equilibrium, the organism remained relatively unchanged for a long time, and then a lot of different things happened to it. And then it remained relatively unchanged for a long time, and then a lot of different things happened to it in a short period of time. So that's really the difference between these two things. And what are these two things? These are two theories about how evolution actually happens. Is it a gradual process of accumulated changes, or is it this sort of stepwise thing where nothing happens for a long time, then a lot happens. Nothing happens for a long time, then a lot happens, kind of like war, right? You know, you're waiting around, and then a huge amount of activity, waiting around, huge amount of activity. So these are two theories about how change occurs. This was the theory that was originally put forth by Darwin, and this is the theory that has more recently been put forth by our friends who have spent all of that time looking at the trilobites. Okay, so there you go. Hope this helped clear up some confusion. Have a good afternoon. Bye-bye.